Hello, 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 and welcome to another Cloud Drops Weekly. I don't even know what to call this one, but we will call this Happy Friday, Happy March 8th, 2024. Wow, here we are, folks, at the end of Q1. You may be wondering why I'm in this suit today. I had a meeting with a client, and we were talking about the virtues and benefits of Kubernetes. More importantly, virtues and benefits of OpenShift and a um, a really robust container Kubernetes platform called Rafay. And Rafe is another one of those solid players in this space where they give you a single pane of glass to manage all of your not just Kubernetes clusters, but cloud infrastructure. They've recently made that inroad into managing additional cloud resources as it pertains to AWS, and I believe more to come. They are a partner of ours here at Think Big Technologies. And I wanted to showcase how to go ahead and navigate through Rafe. But I'm actually going to blend a piece of technology that we were using yesterday, which is OpenShift. And I thought it would be really cool since I had a client ask me, hey, you know what? Is there any scenario in which you would have OpenShift and Rafe under the same roof? So we're going to get right into it. Again, my name is Rudy McComb, founder, CEO, and principal engineer here at Think Big Technologies. We are a cloud enablement, we are a cloud native enablement and Kubernetes first managed service provider. We are 100% US based. There's no offshoring, there's no nearshoring. All of our engineers here are based here in the US. We have been doing Kubernetes for almost going on about 9 years now. And we are here to help your business succeed in cloud native, succeed with AWS, succeed with Azure, succeed with GCP, DigitalOcean, as well as on prem, right? We also do OpenStack, but today is all about Kubernetes, Rafay, and OpenShift. Oh my. So let's get right into it. Let's fire up our Rafay setup over here and let's take a look at what we have. All right. So as you can see, this is the Rafe dashboard. We have a typical layout that you would see across Rafe, across Rancher, across OpenShift, across Tanzu, and we'll do a Tanzu overview some other day. But as you see, where we have a logical grouping, as we talked about yesterday, of clusters and resources, workloads, pods, things of that nature. And right here we have one cluster up. It's a cluster we actually deployed into AWS on EKS. So we have that here. We have workloads, we have pods, we have any violations or alerts that will be listed here. We have that here, and this really gives us a good solid overview of what we can expect and what's going on inside of our environment. We also have audit logs being bubbled up and exposed here through the Rafe dashboard. Um, and if we click on the cluster, we'll get more information. So here we go. We'll go to our cluster. And here we can see the configuration of the cluster. We can see the location. We can see it was auto provision using our cloud credentials. If there were any ingress IPs, we would see that here as well. Rafe utilizes blueprints. So if you want to stay in the GitOps realm, there are blueprints, literally a nice catalog of blueprints that allow you to kind of speed up your provisioning of different components of Kubernetes, and we'll get into that one another time. But I just wanted to kind of show you that real quick. Let's go back over here to our cluster and then roll down the quick configuration overview. It was successful, right? This shows the blueprint sync, and Rafe actually creates a blueprint. They have a default blueprint that you can choose when you deploy into AWS, and that's what I went with for this one. It lets you know if there's a backup agent running. This has not been enabled on this particular cluster. The provision time takes around 10 to 15 minutes, maybe 20, depending on how large your configuration is. This one is very, very bare, very minimal. We can also get information onto managed add-ons. We can see cluster labels as well. We can also get into any AWS tags that we have created or that we want specified for this particular cluster. We have our CNI provider. Right now, we're using the AWS CNI. Had an interesting conversation about that in the Lyft CNI. I'll probably drop the Lyft CNI and the AWS CNI in our chat later on. Let's go back over to that particular cluster. Everything we want one area too deep. Let's go here. Let's see. Okay. All right. So I think we actually finished the provisioning. At the time that it was coming up, it wasn't 100% finished. But let's go back through and get more of our configuration. Let's see here. Let's go over here and look at our. Let's see, this one is not ready just yet. Okay. So this cluster, let's see, add-on, create some blueprint success. Okay. Let's All right, so while this is still coming up and it shows us the events are actually, you can see this still kind of running. EKS cluster for provision successfully. Provisioning system services on the cluster might take approximately 4 to 5 minutes. Okay, so that's why the view changed on this. It went from the actual configuration over to what we had. Let's roll up here to cluster settings. Here's everything else that I configure with it. It's using M5X large. Here's the node AMI family. While this is still finishing, I should have a little treat for us. So we're gonna actually roll a setup that we did yesterday and drop this into Rafay. So let's hop on over to our terminal. Okay. And you can see here, this is our terminal setup we have from yesterday. We'll do a CRC start. What I'm actually doing here, let's actually run a status real quick to see if it's still up. Okay, perfect. So we'll do a start. And I'm actually provisioning a local OpenShift single node cluster here on my Mac. We covered OpenShift development environments yesterday. How to go ahead and set this up. If you would like to know more about that, check out yesterday or the previous video on OpenShift and how to set that up on your Mac. This is using OpenShift local, previously called OpenShift CRC. And while this is coming up, one thing I will note is if you watch the previous video, if you've used OpenShift before, when this finally comes up, you'll get your credential information. You'll also get the URL in order to be able to log into the OpenShift console. Well, OpenShift is one of the main options that you can deploy with Rafay. Um, and the mechanism behind that, right? Rafay, again, as I said before, it allows you to deploy whatever you want to when it comes to Kubernetes. So if we go ahead and click on new cluster, you can create a cluster from a template that they have available, or you can go ahead and create a new cluster. Right now, we'll go over the new cluster. Well, hold on, I'll actually click the template just so you can see. But here you go. Here you can select your environment. So you have public cloud, AWS, Azure, GCP, and you have various options underneath there. You have EKS distribution, AKS, and GKE. You can also click on data center and edge. You can provision using a Linux installer, OVA, OVF, or VMware, or you can use OpenStack. And here we are again in this era of AI. OpenStack provisioning for Kubernetes clusters is becoming more and more the norm as you're looking at organizations who are looking to lower their total cost of ownership when it comes to their Kubernetes platform and footprint. And then we also have private cloud. Private cloud allows you to just choose VMware or just EKS Anywhere bare metal, which is also another offering from AWS, allowing you to utilize EKS and its controllers and all of the nice guardrails that AWS has set up for you on prem. So if you go ahead and choose EKS, you can go ahead and choose the template version if you created one, or the version of the template again if you've already created one. So we're going to cancel out of this because we selected template, and we'll go back here to create a new cluster, and we'll give it a cluster name. We'll call this demo, and here you can see all the different options that we would go ahead and provision with that. So while that's going on, it looks like we had a little issue. And I just realized I'm showing you something while you're watching the terminal. So let's go back over to the terminal and see what was going on. All right, so it looks like the CRC timed out. Let's see, process exited with status 124. So let's run a status on CRC. All right, so it shows that it's running. Since it's running, I'm gonna assume that I can actually do the login. Never assume, but let's see if we can do it. If not, we'll just stop it. Okay, perfect. There we go. So now we're logged in, and let's go ahead and we're gonna do a. We'll jump back over to our browser. Let's check, and I'll run back through this again as far as Rafay goes. But let's look over here at our console for OpenShift. All right, I believe this one is no. 1 second. Let me get that URL from our terminal. There we are. It was right there. Okay. So this is still giving us a failure. Okay. So what we'll do for right now, and I'm curious to see if this will allow it. I will go ahead and do the deployment for actually deployment. I'll do the import of OpenShift into Rafay. So we'll choose data center edge, and you can kind of choose whatever you want to. But we're actually going to choose Red Hat OpenShift, and we'll do local. Continue. And it gives you different options, right? You can go ahead and select regions where your OpenShift container platform cluster is located. And then you can also choose the version. I'm not going to select any of that right now. You have proxy configuration if you are operating in a infrastructure that's behind a proxy, and then you also have system components placement if you would like to add tolerations, daemon sets, node selectors, daemon set overrides, things of that nature. You can do that right here. I'm going to go ahead and click continue. And if you have ever imported into any other Kubernetes management platform, this is pretty similar. You're gonna go ahead and click download Bootstrap YAML. If this was Rancher, Rancher will give you output in order to just run locally on your Kubernetes cluster in order to engage the input and create the different components that are needed so that your cluster can report back to your Kubernetes management platform. In this case, once I go ahead and download this, the local cluster will actually be imported here into Rafay. Now, I will tell you this will not complete. It's a one node cluster, and it's actually doing some duplication because there's already Prometheus running on OpenShift. So we'll see some errors, but we'll also get feedback. So let me go ahead and jump back over to our terminal and we'll continue. Apologies if I'm speaking a little bit fast. This is very exciting for me because if you're in an organization where one team is responsible for, say, the entire AWS or GCP or Azure account setup. And that same platform team is also responsible for providing maybe L3 or senior, whatever you call inside your organization, but that next tier of expert support for Kubernetes. And then you have an actual product team that has their own Kubernetes platform, and they have their own DevOps engineers, their own developers who need to go ahead and interact with Kubernetes. This is a really good way to separate out those duties. And so team A would see Rafay, they would see OpenShift, the status of all of the clusters. And then team B, that product team, they would only see OpenShift and the clusters that they need to interface with. But both teams are able to communicate. You're able to go ahead and get information on what's going on from both ends of the spectrum, and it creates a nice loop. Even in a situation where, let's say, we have changes in the organization, reductions in force, we have new onboarding, or maybe different players have switched teams. Whatever the case may be, you can ensure that your clusters are well taken care of, that they're reporting back in, that you're getting information about what is exactly going on from each cluster, and then as a platform, um, uh, en masse. So I've already downloaded the Bootstrap YAML. I'm gonna go ahead and pop over to my terminal. All right. So from here, this is the same command that you would do inside of Kubernetes. It's the same command that you would do without OC. Red Hat OpenShift has OC as opposed to kubectl or kubectl for those who like calling it kubectl. But you would add the rest of your command line flags, right? So create, get, describe, etc. But we're going to do a OC create dash F. So it's going to create this resource from this YAML file. Ah, error. Okay. So even though I went ahead and destroyed this particular cluster last time, this already exists. So what we can do, let's see, we can do I can still do a delete. Let's run a delete. All right. Oh, denied. Okay. This is denied because I am logged in. Let's see. There we go. Let's see if I can run this again. Will it still deny? Yep, it's still denying. Error when deleting service accounts. Not found. Okay. All right. So let's see if we can do the same thing. Same command. Oh, all right. So this already exists. Do this. Let's do let's do a CRC delete. Let's look at our flags to see what we can do. All right. Delete the instance. All right. Well, let's go ahead and delete the instance. Let's do that. Yeah, so I'm gonna delete the instance. All right. And we'll do a help on this. I believe it's gonna be CRC create. Let's see here. Setup. All right, so we'll redo the CRC setup. Love our flags. Okay. So everything here looks good. Let's see. Open up. Let's see. CRC console. Don't believe this. All right. Let's do start. So I need to delete the previous instance of this, even though I stopped it. All right, so we'll do CRC start. And we'll try running this one more time. So again, went through the setup yesterday. CRC is going to go ahead and check for all the underlying resources that needs to be there, the networking, VF kit, making sure everything is where it needs to be, DNS, so that way you can have a local OpenShift environment. Once this comes up, we'll log in with kubeadmin. After we log in with kubeadmin, we'll rerun our command to go ahead and import this cluster into Rafay. So while that's coming up, let's hop back over to Rafay. Keep an eye on this. All right. Let's see if our AWS cluster is up. Still not provisioned. It's interesting. So it says provision status not provision. The sync is not set, but yet we are showing that the cluster is up. So let's click on it. All right. So we have a status of ready, and the cluster is healthy. Last check in a minute ago. Let's kind of finish up where we left off last time, right? As I mentioned, any node selectors, daemon sets, daemon set overrides, tolerations, you can add that here. You can also view more information regarding this specific cluster that was deployed. You can show the access, security group IDs, cluster security group IDs, subnets, roles, etc. And let's check out our nodes. So here we have our node ID, the IP address, the internal IP address. We also have the node group information and the status on this. And if we expand this out, we can find more information, what's going on with memory, disk, and PID pressure, additional labels, taints, container runtime version, kernel version, kubelet version, the OS image, the CPU cores, memory, GPU information, and then roles. So we'll jump out of this and move over to node groups. So here's our node group name. That node group name would actually match with what's inside of AWS. And as a matter of fact, let me go ahead and bring that up. Let me move a couple of these windows around. And I will show you what we have. All right. So let's go over to EKS. And here is our cluster. And if we click on compute, and you can see down here, here's nodes, and then here's the node group. That node group, right, 005 EF 746 will also match with what's here in Rafay. We can also take a look at our resources. We can explore the cluster this way, look at the pods that are running. We can look at the deployments, replica sets, stateful sets, daemon sets, jobs, cron jobs, load balancer information, config storage, PVCs, HPAs, secrets, and then access control. We also have custom resource definitions here. So all that is listed here. And again, if you want to click on a particular one, you can. You just have to click under actions, and you can edit the YAML. You can restart. You can scale it. You can describe it. You can download it. What have you. Rafay is also compatible with GitOps, so you can hook your pipeline right up here to Rafay, specify your Git repository, and deploy applications that way. Yeah, here's the overall configuration that we started off initially. And here's the EKS managed add-ons, right? So it's currently using the EBS CSI driver. You can also click on and get more information on various resources inside of Rafay. Upgrade jobs, there are none currently running. IAM service accounts, and then identity mapping. You can create namespaces for your clusters. That's another way that you can go ahead and group additional ones. We talked about blueprints briefly. We'll do another session on that at another time. Pod security policies. You can see the default ones here from Rafay, cluster overrides, and then gateways. You can also look at your applications and backup and restore. We're currently not using any agents for backup and restore, but if we wanted to, we would go ahead and create one right here. If we have workloads that we've configured, we can go ahead and do that here. Here's the GitOps section. So we want to go ahead and add up a particular pipeline. We can create that and configure here. Call this test. And then we can go ahead and configure the stages along with the triggers. Approvals, pipeline secret groups, infrastructure provisioners, etc. We also have additional integrations that we can add. So you have Docker Hub, ECR, GCR, K, Nexus, JFrog, Harbor, one of our favorites here. We also have MCR from Microsoft and ACR from Azure. You also have the ability to add a custom registry here. So all the bases are covered. You also have secret stores, secret provider classes, secret sealers, and additional repositories. We also have cost management here. If you wanted to go ahead and configure that, you can get some information in terms of what's actually going on with your particular cluster, right? So enter cost profile name. I have not set this up yet. Let's do test. I believe there's additional configuration we have to do for this. Um, let's see. Yeah, you can specify your region, and then Rafe will go ahead and give you that cost information. We are also partnered with KubeCost. While you can take care of this inside of Rafe, KubeCost hands down has one of the best. Let me take this back. KubeCost is the best uh, cost observability platform that exists today. I know that there are additional offerings out there from other competitors. KubeCost, of course, built on top of OpenCost. Great customer service, a solid platform. And again, if you're interested in utilizing that inside of your own cloud infrastructure, give us a call. Kind of rolling down the line here, we have information on OPA Gatekeeper. So we were to set up any kind of profiles for that, we will have that here. Constraint templates, constraints, policies, policy violations, etc. We also have network policy information here. Again, these are areas that you can come in, tune, tweak, and set up to get the maximum amount of information about your Kubernetes environment. So here is our cluster that we tried to provision previously. This has not been reran since I've been going through the Rafay overview, but let's jump over to our terminal and see if we made any progress. And it looks like we are still just wrapping up here. Okay. Started the OpenShift server. Excellent. All right. And let's click on this and see if we get a solid OpenShift console. Yes, we do. All right. So I'm not going to log in here. No need to do that for this particular test. So let's just stick with what we're doing with the login. So let's log in using kubeadmin. All right. And then let's run that same OC create that we ran previously, or at least attempted to run previously successfully. There we go. All right. So as you can see, Rafay system was created. The service account system SA was created. We have security context constraints, cluster role RBAC authorization, cluster role binding. We have the cluster role authorization, cluster role binding, priority class scheduling for version 3 of Rafay Cluster Critical. Um, we also have the role and role binding for leader election. We also have the CRD here for namespaces, tasklets, and tasks. Config maps for proxy config v3. These are all specific to Rafay. So now that that's done, let's jump back over to Rafay and see what's going on. And we can actually see that here inside of OpenShift, but let's view it from Rafay. So here we are back in Rafay, and it will tell you here that, hey, this is going to take some time to go ahead and import. We'll stay here on the screen and you'll kind of see everything kick in. So as you can see here, we have now moved from the registration complete stage to check-in pending stage. And there's 4 stages when you import a cluster into Rafay. Previously, only half of these add-ons came up. I could have gone ahead and not had these on here, but I just did a default just to demonstrate how you would do this. And as the check-in is pending, you can see other warnings that are happening here. It's showing us that the Readiness Pro failed. Part of these add-ons here, we have Alert Manager, Edge Client, Ingress Infra, Rafay Prometheus, and then Rafay Privilege SCC. And you can switch this view to all, but we only want to see the warnings. And this will go ahead and keep it at that. And there are several, once again, this is a 1 node OpenShift local cluster. Right now we have ready, so Infra has deployed inside of the Rafay namespace. And then we also have the Edge client that's come up. And we've moved from check-in complete to namespace sync complete. Now it's going to do a blueprint sync in progress. This is not finished previously, but again, the blueprints are not necessarily needed for local Kubernetes development. But if you're importing an existing cluster inside of your company, your IT organization, or if you're going to actually deploy a Red Hat OpenShift cluster, all of this would check off. And you can see here, it shows that the blueprint sync is in progress, similar to how we had the view of the test cluster. And while this is coming up, let's hop back over here to our terminal. And let's see. I should check the dashboard real quick. All right, so it's still showing forbidden from that end, but let's pull up the console. That's actually the login for the kube for the command line. And we'll actually grab those credentials and I'll log into the dashboard as developer. So the default for this is going to be developer. All right, so we'll skip the tour. When we covered this in the previous video from yesterday, so definitely check that out. And let's see if we can get our cluster to show. So I'm gonna log back out and I'll log in as group admin. Let's see here. Let's try this one more time. If not, we will just leave it as it is. Next time I do this, I'm gonna go ahead and reach out to a friend of mine and do this at the same time. All right. All right, so it's not showing anything. I believe it's because the cluster is still being overloaded by the Rafay import. Let's do a OC. Let's switch back over to our terminal. Okay. So looking at the projects, we have the Rafay infra and Rafay system. Let's do a get all. We'll do okay. So as you can see, here are all of our resources inside of the Rafay infra namespace. This somewhat mimics what we saw over in the Rafay dashboard. So let's pop that open. Right. And again, like I said, only half of these have completed for me. When I've done this locally, I'm sure if I provided more resources for OpenShift local, that this would actually complete. Probably should also turn off blueprints. But let's go back over to the terminal. And so you can see only thing that has come up really as the node exporter from Prometheus. Everything else is kind of in a state of Kubernetes is like trying to schedule everything, but there are no additional nodes for it to schedule it on. Let's also take a look at the Rafay system namespace so you can see exactly what Rafay drops in there. So here is the Rafay system namespace. Here we have more resources that are up. The controller manager is here. The edge client is also up. The connector V3, V2 relay agent is up. And then we also have 4 deployments: controller manager, edge client, Rafay connector, and then the relay agent. And then here we have additional replica sets and then the ingress controller. So Rudy, why are you showing us OpenShift inside of Rafay? If you're just joining us again, the purpose of all of this is to show number one that this can be done. That Rafay is a premier platform tool for managing additional Kubernetes clusters that also have their own ecosystem. OpenShift and everything that it brings is still something that can be monitored by an additional team. Uh, I would say that you would need to carefully understand what to turn on and what to turn off before doing an import or a deployment of OpenShift. And the reason I say is because there may be things that you want to report back to Rafay. There may be things that you want to keep within OpenShift, or you may want to send it elsewhere. Observability and telemetry information is something that you may want to go ahead and deploy to a unified or a multi-tenant observability stack. Whether that's Loki and F cluster. For those of you who are running Cortex, you may want to send it over to Datadog or Splunk. These are all options where you can send that information out. And so you would not want all of these duplicate systems reporting inside each other. It kind of gets, a little bit inception-y, dreams within dreams, so to speak. So I'm not gonna wait for the rest of this to finish. I did want to go ahead and show you, at the end of the day, how to go about deploying and importing clusters into Rafay and from Rafay. And again, I will show you this kind of overview here before I go to the new cluster. Um, we can see that, of course, the memory is taxed, uh 8 gigs committed, and the master does not have what it needs at all, and that's why the state is it is what it is. This is a previous demo that I went ahead and provisioned, and then this is the actual test that I went ahead and completed earlier for ECAS, which we already went over. When you do create a new cluster from here, and you do go ahead and choose private cloud. Again, you have multiple options for doing that. But just be aware your options for monitoring clusters are not limited to what you have here. You can always import a cluster into Rafay and still be able to get good information in order to know the state and the status of your particular cluster. So that about wraps it up for us for today. Again, thank you for spending this time. Thank you for checking out Rafe and OpenShift. If you want more information on OpenShift, come check out our website at THNKBIG.com. We have information there. Um, and then you also check out the video from yesterday where we actually did the OpenShift local deployment, which we did again here today, but we went more into depth of the OpenShift platform yesterday. And then if you were also interested in running Rafe and want more information on Rafe, what it can do for your organization, how it can help you manage not just Kubernetes, but additional cloud infrastructure, give us a call here. Our phone number here is 512-706-9553. You can also email us, info at thnkbig.com, or you can email me, Rudy, Rudy, at thnkbig.com. Thanks again for spending your time, your Friday. I know you're probably trying to get out of the office, or maybe you're watching this over the weekend. Be safe. Always ask questions, and remember, learning is the most important thing that you can do. So let's get after it. And happy hunting and happy enablement with all of your Kubernetes and cloud native resources. Take care and have a great weekend. Bye bye.